How to design the 12 volts off-grid solar power system. First thing to do is to calculate the daily used power. If we like to use a 10 watts LED bulb, 100 watts electric fan, 150 watts sound system, and 50 watts LED television. They are working on different hours that have a total daily used power of 1000 watts-hour, with the total load power of 300 watts. Now, we calculate a lead-acid battery bank if we use this type of battery. The formula is total daily used power multiplied by 2 and 1.2 in efficiency divided by system voltage. So, we have 1000 watts-hour times 2 times 1.2 divided by 12 volts is equal to 200 amperes-hour lead-acid battery bank. We can buy a one piece of 200 amperes-hour 12 volts battery. We can calculate also the wattage of solar panel to charge this 200 amperes-hour 12 volts battery. Remember the Ohm's law, watts is equal to voltage times amperes. A 12 volts battery times 200 amperes is equal to 2400 watts. And the formula of solar wattage is equal to the battery watts times 0.5 DOD, or depth of discharge, divided by sun peak hours, which is a given 4 hours, depending on which country we live. We have 2400 watts times 0.5 DOD divided by 4 hours is equal to 300 watts, a total solar panel to be used. We have also a formula to choose a solar charge controller, using a total solar panel wattage divided by system voltage, which is 12 volts times 1.25 safety margin factor. Now, 300 watts divided by 12 volts times 1.25 is equal to 31.25 amperes. So, we can use a 32 amperes to 35 amperes solar charge controller. Then, calculate the off-grid power inverter capacity using the formula of total load power in watts divided by 0.8 inverter efficiency. We have 300 watts divided by 0.8 is equal to 375 watts as inverter continuous rating, and multiplied by 2 is equal to 750 watts as surge power ratings. So, we buy a 400 watts inverter with 800 watts surge power ratings. Find also the AC circuit breaker ratings using a formula of total load power divided by AC inverter volts times 1.25 safety factor. We have now a 300 watts divided by 220 volts times 1.25 is equal to 1.70 amperes, or 2 amperes AC circuit breaker that we must install. We can choose also any size of wire conductor as long as above 2 amperes wire ampacity. We can connect like this if we can buy all the materials, including the AC wall socket and switches. Only the solar panel fuse ratings and power inverter fuse ratings are missing on this video because we do not have enough space to connect in the wiring diagram that we created. But we can find the solar fuse ratings calculation and power inverter fuse ratings calculation from the other video that we created before. You can now switch on the AC breaker to run the other connected loads. Switch on the switch of the LED bulb to light on. We can compute also the DC wire ampacity from battery bank to power inverter, using inverter surge power, divided by voltage system, like 800 watts, divided by 12 volts, is equal to 66.67 amperes, minimum wire ampacity, or bigger. And the wire ampacity from solar to solar charger going to battery bank is calculated, using a formula, of total solar wattage, divided by system voltage, times 1.2 safety factor. We have 300 watts, divided by 12 volts, times 1.2 is equal to 31.25 minimum amperes, wire ampacity, or bigger, depending how long the wire from solar panel to solar charge controller. All the wire ampacity calculation result must be based on the wire ampacity chart in order to know the specific wire gauge numbers. Take note that the bigger the wire conductor, which are more than from our calculated wire ampacity, is the more safer the system to operate without burning the wire, and can reduce system losses. Thank you for watching. Please subscribe, like, share, and follow to my channel. Knowledge link information.
I'm staying strong, need to move on to be what I want. I'll keep dreaming on. I'm staying strong, need to move on to be